say them in
All right, here we go. It's now recording.
Start saying them in German.
Is it actually counting?
Yes.
Okay, thank you. You're my savior, Landon. Okay, so we're going to look at it. I hate your soul. We're going to look at it 3 different ways: algebraically, graphically, and numerically. That way we are super familiar with exponential functions. Get very excited. Thank you. All right, open the Flappy for algebraically. Did you bump your little head on Space Mountain?
Almost. It felt like it.
Alright, so it can look like this. There are several ways that we can write the equation. One way is y equals 2 to the x. And that's the pattern that we talked about on Friday, isn't it? When we cut the string? Yep. So is this a growth or decay? Who remembers? It's a growth. It's getting bigger. We can also write it as y equals 5 times 2 to the x. And there was another equation that we had as well. Who remembers? I know, so I'm not asking you.
Oh, y equals 1 half to the x.
Thank you for being able to read the board. Go team. If we had the point strips, I would, but they're at the new school, along with the towers. Now, these are examples of exponential functions. Non-examples are y equals x squared. That is not an exponential function. And y equals 2 times x. That is not an exponential function. This one is a quadratic. This one is linear. Ready? Alright, so it can be written, Blair, you do know how to spell. Oh, sorry. Tell me, Landon, communicate, be my savior. Can be written in the form y equals a times b to the x. Oh, ham sandwich. B is your base, A is your starting point. Is that better? Write it down. Just write it on a piece of paper and you can tell me later. Okay. Alright, are we ready to look at what the graphs look like? Does anybody need a mo? Okay.
Just ignore. Okay.
Pretty much where we're going with y'all in general today. Just going to ignore your table. Alright, so graphically, there are several ways that our graph can look. One way is like this. That's called an exponential growth because it's getting bigger. Isn't it magic? What is that one going to be called? A decay or decrease. Good, because it is getting smaller. And it never touches the x-axis unless you have like a +1 or something out there that shifts it. So do not let it touch the x-axis because it never gets to 0. Non-examples. This is what the graph of y equals x squared looks like that we wrote in the first one for algebraically. That's called a parabola. Hopefully you've heard of those. Bam. And that's the other one. What kind of graph is the second one? Linear. If I could give you a point, I would. Ready? Okay. So we're going to describe the graph. What is the shape of our graphs? What kind of curve? So the parabola looked like a U. What does this look like? An L. Thank you. Alright, so I'm going to draw a line right here. It's an L. You can't see where I drew the line?
It's a line.
It's a line. Like, why are we freaking out? It's a line right above it to separate the sections. Ham sandwich. L-shaped graph. Or a J. A J or L-shaped graph. It has an increasing or decreasing slope. Pew, pew, pew. A bird. Okay, so now that we have identified the noise that birds make, we're going to go on to numerically and talk about what t-tables look like. Are we ready? So we can have t-tables look two different ways, and it's either going to be increasing by multiplication or division. Now our first t-table, I want you to tell me what you think it's increasing by. So my x values are going to be -1, 0, 1, and 2. And my y values are going to be 1/2, 1, 2, and 4. Alright, so how are my y values increasing on the light green one? They double, so would that be times 2? Awesome. How are my y values decreasing on the dark green one? Look at you go. Now this is a non-example, and tell me why. I'm going to use the same x values, -1, 0, 1, and 2, -2, 0, 2, and 4. What are my y values increasing by this time? But how? Are we adding, are we subtracting, are we multiplying, or are we dividing? Adding. That's a non-example. So you can look at it by a t-table and identify that it's increasing or decreasing by multiplication or division. You can look at a graph and see if it's an L or a J shape, or you can look at the equation and see if it has x as an exponent. Now we're going to describe our t-table over here, and then we're going to look at our next foldable. What? Oh, and we're going to do a zombie activity this week about exponents. Is anybody morally objective to zombies? Okay. Sorry. I'll leave you an alternate assignment. It's going to be fun. You get to be infected with zombies and attack each other. If I was here, we would go outside and like really act it out. It's a lot of fun.
Yeah, can you just save it?
Okay. That means I have to find more work, guys.
That's fine. I can help
You
you.
just color.
I don't think I have an exponent coloring sheet, an exponential function
Just
coloring
color.
sheet. No, guys, no. Act like you know me. Come on. I'll find something for you to do, and we'll save it for when we get back. I don't know where we'll go outside at the new school because I haven't been outside there. And I think a lot of it's dirt. But we'll function. We'll do it. All right, are we ready? Okay, are you sure? Go to the next page. The more we get done today, the less you have to do like this of a video when I'm not here. Isn't it exciting?
I guess.
Alright, so now we're going to talk about what the y-intercept looks like algebraically, graphically, and numerically, and what the base looks like. So what is a y-intercept of any graph? You were just like muttering stuff. I don't know what you're saying. Okay. So the question was, what is the y-intercept on any graph? You're just muttering. I can't hear you. Say it again. Look at you go. Yes. So it's where the graph crosses the y-axis. And what is the x value when the graph crosses the y-axis? It's the y value when x equals 0. I don't know if you forgot this or not, but you're pre-AP. And the base is the product that causes the change. Alright, so algebraically, you know how when we wrote on the front that A was our starting point? Over there, that is also your y-intercept. So if you I know. If you have it in the form of A times B to the X, A is the y-intercept. Isn't it crazy? Ooh. So if I just wrote it as y equals 3 to the x, what is my y-intercept of y equals 3 to the x? B is the base, so 3 is our base. What is our A? What number is in front of 3?
1.
An invisible 1, so the y-intercept would be 1. Are you ready? Does anybody need a mo? You need a mo? Okay. Awesome. All right, this is our base. Boom, that's all you have to do. So if I ask you to identify the base of, say, y equals 1/3 to the x power, what's your base here? 1/3. This is your base. So 1/3 is the base. Are you ready for some craziness? Hope so. All right, graph. This is what it looks like on a graph. This is x. This is y. That's your y-intercept, because that's where it crosses the y-axis. Now, finding the base from a graph is a little trickier. So what you have to do when you're finding the base from a graph is you have to find 2 points on that graph. And you know that you can find your y-intercept. So this coordinate is 0, A. And we're going to go right 1 and up however many this is. And we're going to call it 1y. And then to find your base, you do the y value divided by A. So whatever you find this coordinate is, say if it was 1, 4, you would do 4 divided by whatever this is, and that's your base. Yep. You find this coordinate. So if you went right 1 or right 4, whatever you get to the next grid point, and then you find this coordinate, which is your y-intercept, and then you do the y value here divided by the y value here. And that gives you your base. We're going to do some examples, don't worry. Okay, now numerically is a t-table. How would you find your y-intercept on a t-table? We wrote it at the top, but let's see who knows.
So, y, x.
What?
When x equals 0.
Look at you go. When x equals 0, that's your y-intercept. Very proud. I really am proud. It might have sounded sarcastic, but it wasn't. So what is our y-intercept on the t-table on the left? 0, 1. Yep. And what is it on the right? Look at us go. That's it. That's all you have to do. So then we could write it as A equals 1 because that's part of our equation that we wrote down. And here A would equal what? 2. Dun, dun, dun. Now, let's talk about how we find the base from a t-table. Does anybody need a mo? Cool, let's do this. We're almost through. Isn't it exciting? All right, so if I give you a t-table and I say, please find the base of this exponential function, you have to figure out how the t-table is increasing or decreasing. Should be positive 4, not negative 4. I got excited. So the one on the left is a t-table that we've seen before. How are each of these y values increasing? So from 1/2 to 1, how would you increase? Times 2. From 1 to 2, how would you increase? From 2 to 4, how would you increase? So what's your base? 2. All you're doing is looking at how they're increasing. All right, are we increasing or decreasing on this one? And how would we get from 4 to 1? What would we have to do? Divide by 4. Good. How would we get from 1 to 1/4? And 1/4 to 1/16? So what is our base this time? Is it 4 or is it 1/4? If we're dividing. One-fourth. Fractions or division. All right, ready to look at our practice workbook that helps us graph? Act like I'm killing you. Oh, do you want your work? You gonna come get it tomorrow morning? Since you're gonna be gone? Okay. I should have it ready tomorrow morning. Since we don't want zombies, I have to do something else. So I'll find something. Alright, so here, our first learning target for this part says I can find the base and y-intercept given an exponential function, which we can use our previous page to help us with, correct? You just fold it in half like a book. Alright, so let's start by identifying the base of number 1. And if you don't know how to find the base, look back at your notes that we just wrote down. And this is algebraically, so look at the algebraic section. Oh, I'm not going to tell you. You're going to have to look back at your notes and figure out how to find the base. Like we just wrote it down. Tell me what it is.
The basis.
Look at you go. And what's our y-intercept? Awesome. If I could give you a point, I would. Do the same thing for all the others. What the poop? All right, are we ready? All right, what did you get for number 2? What's our base? All right, what's your y-intercept? Good. All right, what's your base here? And y-intercept? Awesome. Is this function, number 1, is it increasing or decreasing? Increasing, because this is a whole number. So this one is increasing. What do you think about number 2? What would it be doing? Decreasing. And number 3? Increasing. Awesome. Alright, now let's look at our graph. Remember, to find our y-intercept, we just see where it crosses the y-axis. So what's our y-intercept here? It's what? 1. Now, to find the base, it's a little more complicated. You have to find the next part where it crosses a grid. So it crosses right here at 1, 3. Do you agree or disagree?
Agree.
Okay, so this is 0, 1. This is 1, 3. And in our notes to find the base from a graph, it said to take the y values and divide them, correct?
Yes.
So our base would be 3 divided by 1, which is 3. That's it. That's all you do. Can you open it and let's look at some more?
Yes.
Yes? All right, let's do this. All right, it just wants you to find the base and y-intercept without me using the t-tables and the graphs. Do you think you can do that on your own? Try it on your own. And then how about Thursday we just practice graphing? Okay? I'll give you equations, I'll give you some t-tables, and we just graph.